Hi, linear algebra students. So I'm finishing up the example that we didn't have the time to finish last class. So we have this matrix U, which is made of 5 vectors, and we are given its reduced row echelon form, which I call R, made of these 5 vectors, R1, R2, R3, R4, R5, respectively. Okay? And we also know that the pivot columns form a basis of Col U. We got that from the class, right? And the question is, what if I remove one of these vectors? Will I still get a basis? Okay, so this is the purpose of this question right here. Is U1, U3 a basis for Col U? Okay, before we start that question, I just want to put down here that U1, U3 will be a basis if it is linearly independent and if it spans the column space of U. Okay? And what we will see is that by removing a vector, you still get a linearly independent. By removing a vector from a basis, you still get a linearly independent set, but unfortunately, you affect the property that the set that you have is no longer a generating set. So let's get started. So property number one, it's fairly easy to see that U1, U3 is linearly independent. So to see that, you just row reduce U1, U3. Okay. So actually, I think I'm going to color code them just to keep track of what they are. So I will use, let's say, orange and purple and red. Why not? So U1 is right here. It will be in purple. And U3 right here in red. So U1, U3. Okay. Is row equivalent. So if you take just these two columns and apply the same row reduction steps, you will get R1, R3. So I'll use the same colors here. R1, which is going to be 1, 0, 0, 0. And R3, which is 2, 1, 0, 0. Okay, so this is it right here. And as you can see, this means that U1 and U3 is linearly independent by the column pivot theorem. So this matrix has a pivot in every column. Therefore, U1 and U3 are linearly independent. So U1, U3 is Li from the column pivot theorem. So just to make it crystal clear, I'm boxing the two pivots here. So we have a pivot in every column. Okay. And for that reason, it's for that reason that U1 and U3 are linearly independent. Okay. So as you can see, property 1 is verified. So 1 is verified. The problem will be the property 2. So we will see that U1, U3 will not be a generating set. So, all right. So we know here that Col U is the span of all the columns. Okay. So Col U is the span of, and let's just write all the columns here. So let's keep track of the columns that I color code, like the U1 and the U3. So it's going to be U1, then U2, U3 in red, then U4, U5 are both going to be in blue. So this is by definition what it is to be a column space. Okay? And now the problem is that U4 is in the span here, but it is not in the span of U1, U3. Okay, so U4 is in Col U, but not in span of U1 and U3. So how do we actually prove that? Well, quite simply, I will erase this now. So we want to study the consistency of the system U1, U3. So U1, U3 slash U4. Okay, so now I'm going to color code the U4 in black, let's say. Or, yeah, in black. Black is the best color I can see for it. So U4 here. Okay. So again, by applying the same row operations, you realize that this is row equivalent to R1, R3, R4. So R1, again, it is like, I'm going to give myself more space, 1, 0, 0, 0. Then R3 is 2, 1, 0, 0. And finally, R4 is 0, 0, 0, 1. Perfect, 0. Okay. And this system is inconsistent, right? So this system is inconsistent. And remember why? It's because we have a pivot in the last column. So this black one here is what makes the system inconsistent. The fact that we have the pivot here, okay? So what it means is that U4 is not in the span of... so U4 is not in the span of U1 and U3. And this is pretty much enough, right? It proves that U1 and U3 cannot be equal to Col U because U4 is in Col U but is not in the span. So as a result, there you go. So Col U is not equal the span of U1, U3, which makes the property 2 false. So as a result, U1, U3 is not a basis. Is not a basis of Col U. That's it. I hope this helps. So the reason why this exercise is important is really that what I meant when I said that a basis can be seen as the largest possible linearly independent set is that as soon as you have a basis, right, as soon as you have a set of linearly independent vectors that generates the space, removing one vector from it will automatically fail to generate the space because of linear independence. So there it is. See you either in the next class or in the next video.